In this video, I'm presenting a dynamic programming approach to the maximum subarray problem. Previously in the reading, I showed a quadratic solution where you looped through with a loop inside of a loop, so that gave big O of n squared time. But let's come up with a linear approach. So what we're going to do is we have to bear in mind that we could potentially receive an array with length 1. The length 1 value could potentially be the largest subarray itself. So let's take a look at -2. -2, the solution is -2. If we have -2 and 1, the sum becomes -1, but 1 is greater than -1. So therefore, this is a solution in and of itself. So let's bear this in mind as we progress. So we're going to start out with -2, and I'm going to keep track of a maximum value and a global value. At this point, all of these should match. In the next step, we are going to say, we're going to take the maximum value, and then we are going to add the next value. So in this case, it'll be -2 plus 1. And this is going to give us -1. If the value is greater than the sum, then we're going to update max here to be 1. If not, we update it with the current value. So in this case, -2 plus 1 is -1. The current value of 1 is greater than -1. So therefore, the max value becomes 1. And if the current max is greater than the previous global, then we're going to update the value. So now we're going to do the same thing. It's going to be 1 minus 3. In this case, it's -2. And now what we want to do, because we have to maintain the contiguity, what we have to do is we're going to put this as -2 because -2 is greater than -3. Since -2 is less than the global, we now have a value of 1. We're going to do the same thing. -2 plus 4 is 2. And we see that 4 is greater than both 2 and the previous -2 value. So this becomes our new max. So therefore, the global is 4. We do the same thing. 4 minus 1 is 3, so the max is 3, and it's less than the global. Now we do 3 plus 2, and that gives us 5. This particular approach allows us to be able to maintain contiguity by having 4, -1, and 2 be found. Because we updated it here, we now were able to say this value should be where our biggest element starts, because we know that there is no subsolution to the left that adds up to 4. So therefore, we don't even care. This is an example of dynamic programming. We're going to see now that 5 plus 1 is going to be 6, so our max is going to be 6 and our global is going to be 6. We're now going to have 6 minus 5, and that's going to be 1. We now see that global has been maintained. 1 plus 4 is 5, so now our maximum is 5, because 5 is greater than 4, as well as 1, and our global remains 6. Then we add the last one. 5 plus 1 is 6, the max is 6, and the global is now tied. This is another example, because if I put another 1 here, it would catch it.